Um, so in this problem, we continue playing with measurable sets and uh, try to understand their properties. The first one is a classical one, okay, and it tells us that if we take two measurable sets, so they are measurable, okay, we want to show that the measure of A union B plus the measure of A intersect B is equal to the measure of A plus the measure of B. So, so what do we know? So first of all, here is A, here is B, and what we have here is A intersect B. So what we're going to do, so we know that A is measurable, B is measurable, therefore A intersect B is measurable. Okay, so now if we look at this part, which is A minus A intersect B, then this one also is measurable, being the intersection of the complement of A intersect B with A, and it is also measurable. Okay, so what do we know? So we know that this set, let's call it A1, and B are disjoint. Okay, so we have A1 intersect B is equal to the empty set, which implies that the measure of A1 union B is equal to the measure of A1 plus the measure of B. Now, what is A1 union B? That is exactly A union B, which implies that the measure of A union B is equal to the measure of A1 plus the measure of B. And finally, what is the measure of A1? So this is the measure of A minus A intersect B, and that is equal to the measure of A minus the measure of A intersect B. Therefore, the measure of A union B is equal to the measure of A minus the measure of A intersect B plus the measure of B, which implies that the measure of A union B plus the measure of A intersect B is equal to the measure of A plus the measure of B. Okay, so the beauty here is the fact that many of these similar problems are a combination of properties of measurable sets and the sigma algebra of measurable sets, as well as the properties of set theory. So one cannot uh, uh, play with measurable sets without having a solid foundation of the properties of sets, okay, from set theory. The second problem, okay, we have a sequence of ENs, which is a countable disjoint. So they are all disjoint sequence of measurable sets, disjoint sequence of measurable sets, or subset of R. And we want to show that the intersection with any set of the union of all the ENs is equal to the sigma of M star A intersect En. So of course this property is valid if we have finitely many sets. So in other words, we do have, thus just because the union is measurable, finite of course, and we have that property for finitely many of them. So it is known, so true, that the measure of A intersect the union of EI from 1 to n is equal to sigma of M star A intersect EI from 1 to n. So this relation equality is true for finitely many disjoint sequence of measurable sets. So what we want to do is to go to the limit and prove that in fact it is true when n goes to infinity. So the argument we're going to choose here is very simple, and it works in a lot of situations. Okay, so first of all, by sigma subadditivity of m star, we have m star of a star intersect, sorry, not a star, intersect the union of all the ENs from 1 to infinity. This is being equal to m star of the union of A intersect all the ENs. This is just a distribution uh, of the properties of the again set theory, I mean distribution of the intersection de Moivre formulas, and this is less or equal than sigma of m star of A intersect the ENs from 1 to infinity. Okay. On the other hand, we have A intersect the union of the EIs from 1 to n is included in A intersect the union of all the EIs from 1 to infinity. So which implies that the outer measure of A intersect the union of the EIs, finitely many of them, is going to be less than the outer measure of A intersect the total union. Okay? Which is also less than sigma of the outer measure of A intersect the En, as we saw before. Now, we said this is equal to this one here, so this implies that sigma from 1 to n of the outer measure of A intersect the EI is going to be less than m star of A intersect the union of all the EIs, okay, for every n. So if we let n go to infinity, then we get sigma from 1 to infinity of m star of A intersect EI is going to be less than m star of A intersect the union of all the EIs, which is also less than sigma of from 1 to outer measure of A intersect EI, which imply exactly what we are looking for.